Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be discussing the concept of dilution. Thinking about what happens when we take a certain amount of a solution and we mix it with a greater amount of water. How can we not only understand the process, but also then undertake calculations to determine what the change in concentration is. So, we're talking about here this idea of, let's say you have a little beaker with a certain amount of solution in it. Okay, so there's a certain amount of water, we've got a certain amount of solute dissolved in it. And then you tip that into a much larger container, and then you add more water. So this goes into here. Okay, we have the same amount of solute, but in a much larger amount of solvent. So our much larger amount of solvent, but same solute. Okay, so we've got more water, same number of solute particles. Okay, it's like thinking about that idea that we've brought up before of how you might make cordial. You know, if it's a bit strong or a bit too concentrated for your taste, then you just kind of add more water to it. You water it down. Okay, and so what we can do is we want to be able to do calculations and say, all right, well, it started at this certain concentration. What's the concentration at the end? Okay, and also then to be able to work out and say, all right, well, if I get it and it starts here and I need this new concentration, how much water do I add? How much do I make it up to get us to that same idea? Okay, both of them are following the same sort of principle. And so the principles that we're working from here is this idea that the moles of substance before dilution equals the moles after dilution. This is the fundamental kind of principle that we're talking about here. We haven't added or subtracted any moles of the solute, but we have changed the amount of solvent, and so that's kind of where our calculation needs to go. Okay, but if we start from that fundamental principle, we haven't changed the number of moles. Okay, so I'm going to introduce you to a kind of a formula that we can use that helps us in this dilution process. Okay, and so but I'm just going to show you kind of how I get there first. So I want you to copy this down, and then I'm going to clear this bit away, and I'm going to write the new formula here. I don't want you to rub out what you've got. I'm working with a fixed space here. So one thing that we know is that the number of moles is equal to the concentration times the volume. Okay, this is the relationship between moles, concentration, and volume. Or we might want to say, you know, so another kind of version of this is that concentration is moles over volume. Okay, this is a relationship that we've seen so far, even if we're not super confident with it yet, necessarily. Okay, so this rearranged becomes this one here. Okay, and so what we've said is that, so let's say we have this first solution, you know, we've made up a solution to start with, and so the moles that we have is equal to the original concentration, you know, a certain concentration and its volume. Okay, and then what we say is that, okay, so let's imagine that we've changed the solution in some way, that the moles that we have in this new situation is the new concentration times the new volume. Okay, but what we've just said before, and this idea here, is that the moles hasn't changed, that N1 and N2 are equal, that we haven't gone to a new number of moles as we've gone from start to finish. So what we can then do is we can actually collapse these two equations together, or kind of connect them together into this one. And this is the one that I really want you to make sure that you highlight, that you underline, so that you are very familiar with it. So the moles at the start is equal to the moles at the end. So concentrate C1 times V1 equals C2 times V2. And sometimes we even just kind of abbreviate it a bit further, but depending on how comfortable you are with that, to even take out the multiplication symbols and say C1 V1 equals C2 V2, knowing that each one has a they're multiplied together. So depending on which bits of information we have, and therefore which one we're trying to find out, we can carry out calculations to determine new concentrations or new volumes. Let me illustrate this for you. Okay, so I'm going to keep this here, and I'm going to do my best to work within the space here. Okay, so we had 100 mils of a 1.5 mole per litre solution made to 500 mils. Okay, so we have an original concentration and an original volume, and then a new volume. So we have C1 and V1, and we have a new volume which is V2. So C2 is the thing that we're after. So now we're going to substitute in what we know. Now, here's a pro tip for you. We're going to convert our volumes to litres first before we do this, because we have moles per litre as our concentration, so we need litres here. Okay, because otherwise you might say, oh, I can kind of do a shortcut. If I kind of put mils in there everywhere, it'll kind of work. Don't do it. Don't do it. Okay, because chances are you'll learn a pattern that means that you'll stuff it up at some point, and we really want you to get good at it first. Okay, do it the right way from the outset. So our concentration, 1.5 moles for every litre, multiplied by 100 mils converted to litres is 0.100 litres, equals our new concentration times our new volume, which is 0.500 litres. Okay, so I'm going to rearrange this so I can solve for C2 equals 1.5 moles per litre multiplied by 0.100 litres divided by 0.500 litres. Okay, and so we get 0.30 moles per litre. Okay, in doing that calculation. Now, there is a bit of a more common sense or kind of intuitive way that you could do a calculation like this, but it doesn't work in every situation. So this is why we kind of want to be familiar with a formula along these lines. You could say, all right, well, I have 100 mils and I've made it up to 500 mils. That is, the solvent has increased by 5. That means the concentration has decreased by 5 because we have the same amount of solute in more water. So therefore, it's more dilute. Its concentration has gone down. And so we can see that this concentration is 1/5 of what it was to start with. And so you could even just use that as a bit of a common sense check in this particular case in order to do it. However, if the ratio is not really simple, like if it goes from 100 mils to 2.5 litres or something, and you're not really confident with the mental maths of that, then that this is where sticking with the formula and substituting accordingly will help you to get the answer that you're after. Okay, so when looking at the process of dilution, we recognize that the moles of solute before the dilution and after the dilution are the same. That we can use that relationship and convert that to a formula, which is C1 times V1 equals C2 times V2. A formula we can now substitute into in order to perform the calculations that we're after. And then we've had a look at one example, and then now the rest is over to you for some practice. So don't forget to like and subscribe. Thanks very much for watching. Bye for now.